Hello everybody, welcome to the Jay Saunders channel. This is Jeffrey speaking. April 15th. Oh, that's tax day 2017. Today I want to do a video where I'm going to explain the processes, and particularly a periglacial process that forms polygons. And I'm talking about polygons on Mars. And we will be going to the photo on Mars pretty soon. And before we go there, I want to show you some things that you really need to know before we go to the big picture. So that when we get there, you'll know what you're looking at. And I'll explain it as we go. And I would also like to add that I've been a geologist for 37 years. So you can trust me when I tell you something. It's pretty likely it's going to be true. I don't guess. I don't see things where there are not things. And that's why I like the JP2 images, because they really show everything. You can't hide anything. And another thing is I'm going to be changing my format a little bit. I'm still going to be doing UFOs and anomalies and ancient civilizations and so on. But, I was a geologist my entire life. I was a chemist before that. Actually, earlier, before I was a geologist. And that got kind of boring, and I changed because geology is just so much more fun. And I'm an outdoors person, so it all fit together just perfect. Now, I can't tell you where I worked because I don't give any details of my personal life away on YouTube. But I do have my own website, and I've always had that. I've had that forever, and I've got probably thousands of articles and videos and everything there. But unfortunately, I can't do that. Give you the address here. And the reason I'm telling you that is I'm getting a little disenchanted with YouTube. It seems that anyone can be attacked by anybody, and YouTube is becoming a kind of a liability now. It's getting kind of scary. So I'm going to continue my channel, but if I ever disappear, it's probably for the better. Because to tell you the truth, I don't really need YouTube. This is just some fun thing I was doing on the side, kind of a fantasy thing at first, and then I got real about it, and I thought, well, this is a nice place to post all this stuff, but I'm beginning to wonder about that. I mean, why do I even bother? So for right now, I think that since there seems to be a lack of geology videos, I'm going to go ahead and just do a lot of simple videos on really a lot of basic things that I think people should know. Like, for instance, when you look at these polygons in these pictures of Pluto and everywhere, okay, those are polygons. But that's all you know. You need to know, I think, what the process is, how they're made, and you will understand what they are better. And there's all kinds of different kinds of polygons. I'm going to concentrate on the ones called stone circles, raised polygonal edges, and for now. So basically, I'm just going to give you basically just a quick lesson on that. And I'm going to use this same exact picture that I've used before to debunk a video where somebody apparently was seeing buildings or something all over the place. And I tell you, I'm a real sucker for going after fake news people, but I think it just isn't even worth it. I'm not even going to bother, And the problem is that I just realized that one person fighting on the evil forces in the planet just isn't going to work out, and I'm just not going to bother with it anymore. Just let it exist on YouTube. So, without any further ado, This is where we'll get the photo. I'll send a link. I'll put a link down below, but these are going to be the polygonal raised ridges polygons. Usually click on this top map here just to get an overview of the map. There are the polygons there. We'll be using the 750 megabyte, which actually weighs in at 733 megabytes. They kind of exaggerated there. And we have 25 centimeters per pixel. And the range to target site is 192 miles. So, we are going right here where that red balloon is. And just to give you an idea where we are on Mars, here's your 4 volcanoes. Here's the huge impact crater. I like this map because I can see where I am on this map. And if you want to zoom in too, you can get some really good relief. Okay. And, well, there's some really strange looking craters here. This thing just kills me. You know, look at that. Okay, so, back on this map, this is the one that this is just the cheap JPEG, but I like it because it uses the shadows. At least it kind of gives you a better idea of what's low and what's high. Now this is a permafrost area here. In fact, all of these areas that are low are permafrost. All this area down here, all this through here, the impact crater is in the edge of this permafrost area. This is a raised area here. This is high. I wish I had a relief map for this, but here's the scale up at the top. It kind of helps to have an idea of what the scale is. So that crater there is about 200 meters across. And now this permafrost, this isn't polygonal area here. This is a different type of permafrost because it's covered with a lot of sand. This is probably sand and ice dunes. Here is the crater. Interesting crater too. This one has been impacted from the left, and you can see because this little square part on it here is actually a hard layer that just got kicked back, because this isn't just, you know, dirt here. This is permafrost, hard ice underneath. There's moisture there. This was a layer on top, and then we have a more viscous, softer layer in between, sandwiched in between. The lower permafrost and the upper strata above the permafrost and above the viscous layer that's in these, that forms these polygons. Now, one other note here real quick is that these polygons, all these dark spots are high ground. These are higher. These are like little almost like mounds. They're not real high. There's a slope. They bulge in the middle, but just enough. And what's happening here is that all of those rocks that you see in the troughs are forming a pattern like this. And this doesn't show it real well, but those maybe back here, they're kind of shaped. Like, see those little bumps in the back? They're shaped. These are like little mounds, and this is usually a viscous kind of a clay ice mixture. It's like permafrost. Here's another picture. This permafrost is very deep, and you get different types here where the ice is moving. You have clay movement here. And let me just bring this, oh God, I did it again. Bring this, I have to remember, use the hand. So you might want to freeze that and read that. The important part right here is freezing of level ground causes the surface to contract and form domed mud polygons. That's what we're looking at here. Gaps between the polygons fill with ice to become ice wedges. In frozen ground, stones tend to move upwards because the buildup of ice beneath the stones pushes them up. At the surface, the stones tend to move down the sloping surfaces of the mud polygons to collect at the polygon edges as stone polygons or stone circles. So these are real common. I mean, it's a common process. It's called a periglacial process. And that's basically how you get these things. Here they are on Earth. That's a real pretty one. And, excuse me. Obviously, there's not a lot of rock here. There's a lot of ice and water available all the time. Here's one in Alaska. These are like sand dunes. This is the same thing. Unconsolidated sediments. Very viscous here. We have layers. This is Pluto. This is a different type of polygon, but they're still polygonal. Here we are on Pluto again. Nitrogen ice flows. More polygons. Same process. Okay. So, and then just quickly some notes here. That if you come up here, you always use this top one as just a reference map kind of a thing, like I used here. You can click here. You should probably freeze that. Read the bottom here. Thermal contraction polygons are the most common periglacial feature on Earth. The results of seasonal cracking of ice-cemented soils. So, and now, such characteristics can distinguish permafrost polygonal patterns from other polygon-forming processes, such as giant mud cracks or lava cooling cracks. See, so we have all these different processes that form polygons. But we're just going to talk about the stone ones. You can go through, and there have many photos here. You click on have the science theme. Always stay with your theme. Glacial and periglacial processes. They've got thousands of these things. Thousands. And you can look at the overview map. This one I like because if you look here, you can see the little lines in the little tiny sand dunes, little lateral sand dunes. And it looks like a lot of stuff to see in here, really. I probably should have picked this map, but I don't. These are polygons here too, believe it or not. Look at the same map, and we're back to there again. So I think we're ready to jump into the big picture. So here is the JP2 image. This is the clearest, sharpest image that you're going to ever see of Mars. So let me come into the crater first, because we want to get our bearings on our size here, on our scale. We want to know, where are we? That crater is 200 meters, maybe a little less. Looks like about 50 meters deep. And you can see the impactor came from the left, hit here, and almost, I don't know how big it was. Might even be still there. But because this is a layered ground, we'll get this kind of a square edge on it here like that. If this was a lot softer, that would be more uniformly shaped. It'd be oblong, but you know, it wouldn't have this big square part, and that's because we've got different layers here. We've got permafrost on the bottom with this icy soil in between, and then dry on the top, which is a lot of debris, dust and dirt, because Mars is just a big dust bowl. I'm going to come over to the polygons here. Let's zoom in here real quick. I want to do this very quickly, because time really does tick away here when you're doing this. So here we have the polygons. I'm just going to go ahead and zoom in on them, because what we really want to see is the rocks around the edge. And I want to explain that if you... And these are pretty clean, but you can see there are rocks. See these little rocks all over the place, little stones laying all over? These stones come up from the bottom here, from the permafrost layer, and maybe even below that, but these stones are forced upwards, and they get to the top like this one here. And they eventually just get worked and pushed over and to wherever downhill is. So in this case, back out a little bit here. Okay, so these are all polygons, stone polygons. These are kind of unique as far as this process goes. It's kind of neat the way it picks up the rocks in the middle, and this is so clean. Makes you wonder how long does it take for the rock to hit the surface and then get to the side. But that's where they end up over here. Now if we head down a little lower, we can see that this area of permafrost is older because there are more rocks. More rocks have been pulled to the surface. If we go down here, we see what I believe to be newer polygons, because there's not that much rock. It's been pushed to the side. I don't think it's because there isn't any rock available. I just think that they're newer. These are, and there's a different color. They look rougher, like there's a lot of rock still coming up. The process is still bringing rocks to the surface. Okay? And then we have, oh gosh, I went out too far. Areas like those circles. Now, what would you think that those circles were? Well, zoom in here. Oh man. Well, what does that look like? Well, that's a crater in a viscous liquid. Not a liquid as you would think liquid. But you don't know when that crater hit. That crater probably was made when there was a lot more moisture here. I'll take a look next to it here. Thought I saw something. No, nothing there. We already know there's nothing on the crater. We did look at that, didn't we? Up here, I want to also show you this area. I don't know if I mentioned this already, but this is another area of permafrost here that looks like it's like a wind-blown surface on it here. So we have winds going this way, apparently. And those are, I don't think those are sand dunes. This is a characteristic of this type of periglacial activity. This is a low area here. And you know why I know? Because when I go back to this map, that's why I have this thing handy, because I can look at this thing and it tells me that I'm in a low area here. I can back that out. You can tell easily now it's a low area. This is a shadow. We know the sun's coming from this way, from the lower left, so that's a shadow. So that's a high spot. This is all low. This is the side of a it's like a hill. Okay, so we go back over here again. There's a problem sometimes with the high, super resolution here. They do tend to be a little light, and you might even have to put a filter on them. But I don't like to mess up the photo, except maybe to put a light filter on it. Now here we are on this light ridge, and you can see it up the left here on the navigator. So we're looking at high ground, but this all looks like it's still permafrost. Okay, so back to the polygons. Now when you see these, you'll know what's going on. There's a constant process of expansion and contraction, heating, cooling, and so we have this constant movement of the ice, and this process going on here. Doesn't matter if you're on Mars, it doesn't matter if you're on Pluto or Earth. You get the same thing. It's the same exact process. So I just wanted to take a look at a couple other places, like maybe right here. And we'll check and see this area between the permafrost and that area. So this is like a transitional area from the permafrost, which is active, to this area here, which probably has permafrost on it, but the surface is just a different, material. It's not level enough. It's got to be a low area. It can't be on the side of a hill or something. It's got to be flat. And if we zoom in here, we can check out these stones over here. Anything unusual? Yeah. And over here, see some unusual looking stones. But if you, and that's what's handy about this high views, you can measure all this stuff. How big is that? Oh, look here. It's 20 pixels, right? So that's, unless I'm seeing a 9 or a 0 on that. That's 29. So we've got 30 pixels times 25 centimeters. That's how big that's how big that rock is. Okay, how about this rock? How big is that one? Oops. Oh, come on. Oh, you're not going to measure me? That's 20 pixels. So that's 20 times 25 centimeters. That's what, 400 centimeters? 400 centimeters is 100 inches, so it's like 9 feet. So that's 9 feet long. So if there was somebody standing there, well, you'd probably just see their head. You wouldn't really see their body that much, because this is only at a 7-degree angle. So if you're looking at, somebody was showing you a super high resolution photo of Mars. You would expect to be able to see just about everything. And if a geologist looked at this and said, no, those are all rocks and stones, there are no structures there. If somebody came along with a different picture, was not a geologist, and showed you a fuzzy picture and said, there are buildings there, who would you believe? Well, I don't know. But like I said, I spent a lifetime doing this. That's probably why I didn't do that many geology videos, is because, you know, you do it for 40 years. It just doesn't seem important to do videos. But then I realized one day, you know, because when you look at the comments that you see on a lot of these channels, the people, 99% of people are not scientists. They don't have a clue. And sometimes it's hard to imagine not having a clue. And you'd be surprised what a small amount of information you can give to somebody and to get them interested. Because once you start to understand things, they become more interesting. And that's the whole key to learning, is you need to be interested. So I'm going to be doing more videos that have just the more geologic nature. And they may seem boring because there are no flying saucers, there are no imaginary buildings, there are no imaginary roads. But if you think about it, why would you want to waste your life on something that isn't real? Well, you wouldn't. Believe me, when you, later on, you'll start thinking about things like that, going, wow, how much time did I waste just looking at these fantasy, you know, subjects where nothing is there. It's too inconclusive. So I think I'm just going to go ahead and do some more videos on geologic studies, but I'm also, I will still do the UFOs and everything else. So anyway, there you go. There's your free lesson on how polygonal structures are formed. And so now when you see them, you'll know what they are. And you can impress your friends and say, oh, those are polygons. I know how those are made. So until next time, I'll try to come up with something a little more interesting next time, but it will be on Mars because I've got 48,000 pictures to go through here. Okay, so have a good day, and I will see you next time. Bye.